generated by these companies. It has more than 1 million data per hour. So more than 1 million transactions which it encounters across the world in an hour. So it tells you how much data is actually being generated by the firm. If you see the market size, it is 53.4 billion market size in 2016, which is growing, which grew to 57 billion in 2017. India itself is a $2 billion market, and which is increasing eightfold, and it's expected to become 16 billion market by 2025. India is among the top big data analytic market. We have data scientists, data analysts, big data engineers. These are the roles that individuals will play. The largest market in the world is North America, followed by APAC countries, Asia Pacific countries. This is basically because the industries, manufacturing industry is growing in these regions, and the data centers are growing basically in India and China because low labor cost. Much of the MNCs, they're also setting up their manufacturing base either in India or in China. And therefore, India will emerge as a large market for big data. It will emerge as a large market for big data. Now, a market is also segmented on the basis of functions or on the basis of components. So we call it on the basis of functions or on the basis of components. So we have a software market and we also have a services market. So there is a software market and also the services market. So market is seen also in terms of software and services. Software includes data analytic, data discovery, data visualization, and data management, while services includes consulting and system integration, training and support, and managing services. Now, it is what is basically big data? Basically, the amount of data that is being generated because of multiple sources is huge, that we cannot use the traditional method for searching through or through this data. So we say it is an all-encompassing term for any data set that is so large and complex that it becomes difficult to process using traditional data processing application. In simple words, the data that is being generated today is so huge and so complex. Why we say complex? Because there are a variety of sources and there are a variety of data. Like we have structured data, we also have unstructured data, we have video, we have text, we have blog. So there could be unstructured data also, which gives you, which has 80% of useful information. So it's a huge amount of data and a huge variety of data which is being generated every hour. And because of which we are not able to use a traditional method to store and analyze it. So it's a all-encompassing term we use for a data set so large and complex that it becomes difficult to process using traditional data processing application. Now we define big data in terms of 4 V's. Volume, that is the volume of data generated is very high. It is 2.5 exabyte of data per day. Now 1 exabyte means it is a 1 followed by 18 zeros. So you can see how much data is being generated per day. Exabyte is 1 followed by 18 zeros. So it creates 2.5 exabyte of data per day. And this is because of increase in source. There are so many sources from which data is being generated. Then variety. The variety of data earlier was only structured. Now we have structured as well as unstructured data. Structured is that we have created, like purchase transaction. We have a structured format for tracking that data. Whom did we sell? How much did we sell? What price did we sell? So on. So there's a structured data. Unstructured data could be in any form. Somebody has taken your service, he puts a blog, he's not happy. So that also is a data, that's unstructured data. So unstructured data holds 80% valuable insight for the business. So it could be mobile data, social media data, chat, blog, video, it could be anything. So there's a variety of data today that we are dealing with. Then velocity of data. Velocity is the speed. The speed at which data is being generated is very high. The rate at which data is generated and processed is very high because of increasing power of computers, because of increasing processing power of the computers, increasing connectivity and more ease to communicate. So the velocity, the speed at which data is being generated is also increasing. And the last V which has been added is veracity. which is inconsistency. Now we are generating so much data from so many different sources. Some of the data might not be very useful for us. So this is called veracity, or what in other words we call noise. So we should be able to eliminate which is relevant for us, and which data is noise, and which in fact is not which does not add value to us. So we should be able to segregate between the two. We should be able to segregate between the two. Veracity is inconsistency, or noise, quality of data. So there are 4 V's: volume, variety, velocity, and veracity. Now there are many sources like internet, like the social media data is data, primary reports which has been conducted by survey, experiment, observation, secondary report, industry report, consumer reports, location data, that is your mobile data, satellite data, which is your image data, device data like RFID or sensors. Now the problem is there's too much time and too much cost which is needed to load all this data into traditional filing system. There's too much time and cost which is required in order to load this data in relational tables, in the tables that you have, structured tables that you have created. So there's too much time and cost lost in loading the traditional relational files. So we need a new approach to managing data. So what we need is a new approach to manage data. So what is big data analytic? It allows you to analyze a mix of the structured, semi-structured, unstructured data to search for valuable information and insights. The aim is to provide an organization with actionable insights for smarter decision making and for better business outcomes. Big data analytic is a process of examining large data sets containing a variety of data types, structured, unstructured, to discover or uncover hidden pattern, unknown correlation, market trend, customer preference, and other useful information. So what we do is we sift through that data to uncover hidden pattern, unknown correlation, market trend, customer preference, and other useful information. So it is important to understand what each analytic type delivers and to match the analytic function with the organizational capability. So there are 4 types of analytic: descriptive, diagnostic, prescriptive, and predictive. Descriptive talks about what? Which uses business intelligence and data mining to ask what exactly has happened. So it investigates as to what has happened. So it uses trend related information on past events. So whatever has happened in the past, it analyzes it and describes what exactly has happened. Diagnostic describes why, which uses business intelligence and data mining to ask why it has happened. So it looks into the past trend and investigates as to why it has happened. Predictive says what could happen, which uses statistical models and forecasts. Depending upon past trends, it forecasts the future and predicts what could happen. It helps managers anticipate likely scenarios and to plan ahead what could happen. Prescriptive is what should happen. It uses optimization and simulation to ask, what should we do? It explores possible actions and suggestions. Based on descriptive and predictive, they build on each other, with descriptive being most common and prescriptive being most advanced. So prescriptive sees what has happened in the past and uses optimization and simulation to suggest exactly as to what should happen. So there are 4 types of analytics that we use. Descriptive analyzes past trends to indicate what has happened. Diagnostic analyzes past trend to indicate why it has happened. Predictive analyzes the past trend and predicts the future to show what could happen. And prescriptive uses optimization and simulation to ask what should happen. The technology used is Apache Hadoop, managed by Apache Software Foundation. Hadoop is an open source software framework written in Java for distributed storage and distributed processing of very large data sets. The storage part is called Hadoop, distribute filing system, and processing part is called MapReduce. So this is big data. What is big data? It is an all-encompassing term for data set which is very large and complex, that we cannot process it using traditional traditional processing application. So we need a new approach to process the data. There are four characteristics: volume, variety, velocity, and veracity. And there are four analytics: descriptive, diagnostic, prescriptive, and predictive. Now let's move to the next topic, which we mean by cloud computing, which is cloud computing. Now, each one of you must have heard the term cloud. We say put the data on the cloud. So this means it's an online storage wherein we keep our corporate data, and this online storage is accessible by everybody, by people in the corporate sector from anywhere. So even if you're traveling, you don't have to carry data. You can access data from the cloud. So cloud computing refers to a computing environment in which storage and software is provided as an internet service, and they are accessed by a web browser. So storage and software is provided as an internet service. So as an internet service, your data is stored, and even the software you can access, and they can be accessed by a web browser. Now, why this has come about? Because as internet connection speed increases and wireless access also broadens, we have more ease in connectivity. More computing activities are being delivered over the internet rather than installed in simple PCs on your desktops. So as internet connection speed increases and wireless internet access broadens, more computing is being delivered over the internet rather than software installed on PCs. Now, why the term cloud computing? The term comes from the word from the use of a cloud in a network diagram. So there are many clouds connected to each other. So to represent the internet in an abstract sense, it's basically referring to the internet in an abstract sense. Most computing will take place on internet servers through web browsers. All communication, photo, contact, document, music, media, all is available through the internet, will be available from any internet connected devices. FB provides social interaction and can store personal photo. Google and Yahoo store email along with calendars, photos, and also you can create a to-do list that we often do. We create a to-do list. So we use the term cloud to refer to the internet in an abstract sense. We use the term cloud to refer to the internet in an abstract sense. Now, cloud computing service providers, those who provide these services, they manage the services like any other utility company, like somebody who is generating power and distributing power. The way he will be charging you, similarly, the cloud computing service providers also charge you. So cloud computing service providers manage their service much like a utility company manages its resources. So processing and storage needs of all its clients can be spread over numerous servers, and as business grows, more servers they add, and as one fails, others pick up the slack. So as and when you need to increase the number of services, you can add more servers. The benefits is you can access anywhere. A company can outsource information system to the cloud. You don't need to design, install, maintain, look after it, access corporates, and you can access corporate system from anywhere because of online storage. So you can access from anywhere, and you don't have to maintain your own. You don't have to design, install, maintain, and look after it. We move from a capex to an opex model. Capex is capital expenditure. CAP is capital. EX is expenditure. So we had to make a capital expenditure in order to install the system, design the system, install, maintain. Now we don't have to do. So we move from a capex to operating expenditure. OP is operating, EX is expenditure. So we move from a capex to an OPEX model where we don't make a capital expenditure. We only pay for the services used. So we just pay the operating expenditure. Independence of location and device, you can access anywhere. Maintenance, it's easy to maintain, but you don't have to look into it. It's multi-tenancy. It enables sharing of resources and cost across a large pool of users. The service provider, to him also it is beneficial because he set up this provision not for one company, but for 10 companies. So it multi-tenancy, it enables sharing of resources. So whatever the cost is, it gets shared across multiple users. It enables sharing of resources and cost across a large pool of users. Productivity is increased as multiple users can work on the same data simultaneously. So if your corporate data is in the cloud, you can access it from home. Somebody can access it from some other city. So increased productivity increases as multiple users can work on the same data simultaneously. It can be accessed by multiple managers from different places. Scalability, more servers can be added on demand, so it is a scalable model. Reliability, it improves with use of multiple redundant sites, which makes well-designed cloud computing suitable for business continuity and disaster recovery. Performance is monitored and is consistent. Security improves because of centralization of data. Now, what are the methods? These were the advantages of cloud computing. These were the advantages of cloud computing. There are n number of advantages. The advantages are you can access anywhere because of online storage. We move from a capex to opex model. There is independence of location and device. Maintenance is easy. Multi-tenancy is there, enables sharing of resources and cost across a large pool. Productivity is increased. Scalability, more servers can be added. Reliability also improves. Then performance is monitored and consistent, and security is also maintained. Now, there are 4 methods of deployment: public cloud, private cloud, hybrid cloud, and community cloud. Let's take the first one, public cloud. When services are rendered over a network that is open for public use, so any individual or any corporate can access this cloud. Therefore, it offers services to the general public, to individuals, and also the corporate or the company. These services are free. The providers are generally own and operate the infrastructure at their data centers, and access is generally via the internet. Google and Microsoft are examples of a public cloud. So when services are rendered over a network that is open for the public use, it offers services to the general public, to individuals as well as corporate sector, and services are free. Private cloud. Now, cloud infrastructure is operated solely for a single organization. So whether it is managed internally by you or you have given it to some outside party to set up the cloud for you. So cloud infrastructure is operated solely for a single organization, whether it is being managed internally by your team, by your own members, managers, or by a third-party organization. So it could be hosted internally or it could be hosted externally. It requires significant level and degree of engagement. So you have to be involved in it to virtualize the business environment and reevaluate decisions about existing resources. Every step in the project raises security issues that must be addressed to prevent serious vulnerabilities. There are self-run data centers, and therefore they will be generally capital intensive. It requires allocation of space, hardware, environmental controls, requires additional capital expenditure. Users still have to buy, build, manage them because it is against the economic model of cloud computing. Cloud computing, basically, we focus on the economic model. So if we create a cloud, we enable multiple users to access it. The moment we allow multiple users to access it, the costs get distributed among so many users. So in a private cloud, the cost has to be borne only by you. So it is against the economic model of cloud computing. So every step it requires a huge involvement, level of engagement. Every step in the project raises security issues that must be addressed to prevent serious vulnerabilities. Self-run data centers are there. It is capital intensive. You have to allocate space, hardware, environment control, capital expenditure. Users still have to buy, build, and manage them. And it is against the economic model of cloud computing. Now, hybrid cloud. Hybrid is a combination of both private and public. It's a composition of 2 or more clouds: private cloud, public cloud, community cloud, that remain distinct entities but are bound together. So in a hybrid, you'll have private cloud also, public cloud also, community cloud also, and they're bound together. So it's a composition of 2 or more private clouds, 2 or more public or community cloud that remain distinct entities. So they are distinct. This is private, but then they are also bound together. It offers benefits of multiple deployment models. Some business combine public and private cloud service. Amazon, like for instance, Amazon.com allows companies to create a private cloud on its public cloud infrastructure. So Amazon has it's open. It's like Google or Microsoft. It's a public cloud. So, but then it allows companies to create a private cloud in that public cloud infrastructure. It allows companies to create a private cloud on its public cloud infrastructure. Now, it crosses isolation and provider boundaries and it cannot be put in any one category. So we cannot say it's a private or it's a public. It's a combination of the two. It allows one to extend either the capacity or capability of a cloud service by aggregation, integration, customization with another cloud service. One company stores sensitive client data in-house on a private cloud application, but interconnect that application to a business intelligence application provided on a public cloud as a software service. Now, what is cloud bursting? Now, this is a term which is we should be familiar with, which comes in case of hybrid cloud. IT organization use public cloud computing resources to meet temporary capacity needs that cannot be met by the private cloud. This capability enables hybrid clouds to employ cloud bursting for scaling across clouds. So what happens? You have your cloud computing resources, but that is not sufficient. So you have to move beyond, and that is what we call cloud bursting. IT organization use public cloud computing resources to meet temporary capacity needs that cannot be met by the private cloud. So private cloud does not have that needs, does not have that capacity, does not have that requirement to fulfill that need. This capability enables hybrid clouds to employ cloud bursting for scaling across clouds. Cloud bursting is an application deployment model. Application deployment model in which an application runs in a private cloud or a data center but bursts to a public cloud. So when you don't have that facility within your private cloud, you take that benefit from a public cloud. So that is called cloud bursting. It is an application deployment model in which an application runs in a private cloud or data center and bursts to a public cloud when demand for computing capacity increases. It's an application deployment model in which an application runs in a private cloud or a data center and bursts to a public cloud when demand for a computing capacity increases, and that capacity the private cloud does not have. So that is what we mean by cloud bursting. Now the last is community cloud. Several companies, they share cloud computing resources. So they come together, 4-5 companies, and they share computing resources. So whether it is managed internally or by a third party, either hosted internally or externally, the cost is spread across these 4 or 5 users. These organizations are from a specific community with common concerns, common security concerns, compliance concerns, jurisdiction concerns. So they come together. So 4-5 companies, they come together and they create a common cloud and they share the resources. So the costs get distributed among them. That's a community cloud. So several companies share cloud computing resources, whether managed internally or by a third party, either hosted internally or externally. Costs are spread across fewer users as compared to the public cloud. So we share it among those 4 or 5 users, unlike a public cloud where it is shared across so many users. These organizations are from a specific community with common concerns like security concerns, compliance concerns, or jurisdiction concerns. So what is cloud computing? When we store our resources on the cloud, and even the software and storage services are taken from the cloud. The term cloud is used to refer to the internet in an abstract sense. And there are so many advantages that we get of cloud computing. And there are 4 deployment models. One is a public cloud, which is for individuals and companies, which is free, like Google, Microsoft, Amazon. And then a private cloud, which is created for a specific company. So it is a capital expenditure. You have to look into maintenance, a huge level of involvement and engagement involved. And it is against the economic model of cloud computing. Then hybrid cloud, when it's a combination of the two, like Amazon allows companies to create a private cloud on its public cloud infrastructure. Then community cloud, wherein a group of companies come together to create a cloud infrastructure and they distribute the cost. So it is an economic model, but it is not as economical as a public cloud. So these are the 4 deployment models. So we are over with big data analytic, and cloud computing. So that is, we have taken up 2 short topics today. Tomorrow we will take up crowdsourcing. Any query you have, anything you want to clarify, discuss? Yes, Kavita, Lata, Nazneen, Bakas, Muskan, anybody, Mojis, Kamran, I can see some of the names, Danish, Abuzar. Anything you have to clarify? Anything you want to ask? Jasmine, Hayat, Nuruzaya.
मैम कल टेस्ट होगा या नहीं?
No, people don't want it. They say that some people in the family are not very well and they're not able to concentrate, that's fine. I'll shift it for a week. Maybe I'll take it coming Saturday. So that gives you sufficient time. But I will engage the class tomorrow and try to wind up with as much of the course as possible. Is it okay with you? I wanted to take it because it has to come, and it'll all be piled up together right at the end. 25th May, I think, is your last working day. All of you will get n number of assignments starting from, I'm telling you, 18, 17. So I just wanted I could take an assessment, but fine, that's okay. That gives you 1 week more time. Prepare.
Ma'am,
That's why
what about if somebody want to
I'm
give
not
test tomorrow?
pressurizing you to go through the entire course. So I just told you 2-3 topics if you can prepare, and we can just interact to assess how much you have gathered. But I'll take it next week. That gives you sufficient time. It's okay with me. I think I don't want to stress you because as it is a very stressful situation for all of us. Okay, we call it a day, but tomorrow I will engage your class in the scheduled time. I will let you know accordingly. Okay, can we call it a day?
Thank you.